So hello everyone. So some of you may remember me from yesterday. So I was giving the post-translation modification lecture yesterday. And today I will show you the Perseus tutorial for this computational PTM. So I prepare a few slides before we start interactively working on the Perseus. In order to run your post-translation modification analysis on the Perseus, we need to have two things. So you need to have your Perseus annotation, and then you need to have the phosphosite plus data sets. We will have this, we will need these two data folders, but they will come to different locations. And then you can download actually a Perseus annotation on the Perseus. So let's go. And then let's start our Perseus. Francisco already showed, but I just want to again mention. So here on the tools, on the annotation, you will click on this link and then you will get annotation. And then for this data set, for this analysis, we need Homo sapiens one. And the second one is phosphosite plus. And then we go to the phosphosite plus. And then here we will go to download dataset from PSP, and then you will agree on it, and then you will download your modification of your interest. So you can download all of them. You could also download only the phosphorylation. Okay, so we need to make sure that these are over on your Perseus. And then our dataset. So the data set, again, the same from yesterday, the one that I was mentioning from Curtis data. As you may know that we have MaxQB, and what is MaxQB is the MaxQuant database. That there are a few project folders there. And then here we go to the projects, and on this project, this HeLa deep proteome is the data set that I will use. And then I go to the data. And then here is the phospho-SDY. You need to have phospho-SDY or any other modification of your results. So at the moment, we are using MaxQuant output table. So let's talk about what was this data set. So our data set was the large scale and label-free and phosphor proteomics data set. And then in this file, we have three different conditions. And then the first one is the control, and the other one is mitosis, and the third one is EGF. So what we know this on mitosis is that we build those phosphorylation events, and on control, we don't see as much as mitosis. On our modification sites table, we have some information that we require for this PTM analysis. First, the intensity underscore 2 and 3. Okay, and Daniele just says what was these intensities are standing for, but what about this underscore 1, 2, and 3? So this underscore ones representing the data that the identification comes from only singly phosphorylated data set. There's only one modification on this peptide. And underscore is there are 2 modification sites, and underscore 3 will be 3 or higher modification sites. They are the modification of your interest for phosphorylation. And the second one is the localization probability. As you may remember yesterday, I was saying that there are some classes that we say, for instance, class 1 is the probability is bigger than 0.75. And then some of the 3 more things might be also useful for your PTM analysis, like amino acids, the name of this modified amino acid. Since our table is only phospho-SDY, that will be either S, T, or Y. And then we also have the sequence window. So sequence window is we found our modified sites, and then we add some amino acids before and after. In the current version, we have 15 amino acids are adding before and after. We have 31, and then that's why it's like a window. It's not like peptide, but it will be, this information later will be useful if you want to go for other databases. And the position is the position of this modification in your protein. And for your phosphor analysis, we have modification tab. On this modification tab, we have some specific Perseus processes that you could get more information from various sources. And then that's where we will go through it. And then the general idea is still the same. So we will prepare our data set, and then we will do some statistic tests, and then we add some modification specific information on top. And here, the things that I show red, they are specific for the modification. So let's go to our, so I told you that we need to have annotations. Annotation is my main, Homo sapiens is under our com annotation folder. And then we have PSP, we have our data sets here. We are ready to start. So I'll close it just to be sure. First, we load our metrics. Phosphosite plus. So Francisco and Daniela already mentioned about the mains, but in this case, we don't have the mains, but we have to tell which columns we are working on. So we are working intensity underscore 1 and 2. They're actually 6, but to make it simple and faster, I will actually go for 4 per each. Okay, so the intensities are our main, and the localization probability was also important and is here. And then we will also later need the sequence window, and we also have it on our sample. So, okay. It's loading. Okay. Okay, the first thing that we clean our sample now. First, we remove the categorical column. We don't want the reverse, we remove them because this has some other purpose. And we remove the contaminant ones. And then we can rearrange the column. It's like practicing also because there's a lot of intensity. So let's give it a try. Okay, so let's have a look. So we have 36 column, and then we still have 36 column. And compared to the original, let's rename it. Let's say this is original data set matrix. We have a bit less. I rename it. So now the second thing is I will now filter. And then this is the thing about the filter the rows based on numerical volume. Our data set has all this information, all this localization probability. We want to keep the high confidence one. We are filtering row based on the numerical column called localization probability, and the relation is x, because here is x is bigger than 0.75. And we want to reduce the matrix. Okay, and then we can now transform doing the basics. We don't need to change anything here. And then this is now the first modification specific process, expand the site table. So when we go also over, it says us, it rearranged the metrics based on the _1, 2, and 3. So we don't need to do anything, and then you will see that this C1 _1 _2 and 3, they are actually merged and to the one column C1. And then if we also look at generally how many columns we have, 36, we have now 12, because every 3 column that this underscore intensity was related, it became to 1. But we have much more rows because all this information came per row base. Since we merged them, here we have a new column called multiplicity. The one representing the _1, and if you go down, you will see 2 and 3. And then before we start go a bit more, let's now create the column like the Francisca and Daniela were doing. We annotate the rows, and here create annotation rows. I told you we have 3 samples, so and then 3 groups, and then they have 4 replicates. We say C. They're all coming from control. These are all coming from E15, and they're all coming from N. N is the mitosis. Then we say okay. Okay. I need to remove this a bit. Oh, okay. Okay, and then we are now filtering based on the valid values. So I want to have 70%, and I want to go in total. Of course, you could also say per group, I want to have 70%, but yeah. So this was in total, I have more. And then let's have a look. There's some NA, and then what can I do? Yes.
Can you repeat the filter row step?
You mean here?
Yeah.
Oh, okay. So here I was here on the filter row. I didn't go in deep because it's been already mentioned previously. And then I want to filter rows based on the valid values. And I keep only the percentage wise, and I didn't change the mode. Mode is still total, and I want to reduce the matrix. In order to show the same steps, I actually started again from the same matrix. So now I have a new branch. And because I have some missing values, I will do some imputation. So you could try the other settings here, but the purpose of the tutorial, I want to show the normal distribution. I'm not going to change the settings. You can play if you want. And then you could do the histogram. We did the histogram. And then here, for every group, every control 1, control 2, 3, and so, we have the distribution. And then you can see where the imputation happened. Okay, now our data is ready. And what we will do sample test. Daniela just explained, so I will not explain any further. On this case, I keep the settings as default. I just go to test on the processing, multi-sample test, and okay. And on this matrix, we now have a column called ANOVA significant. And then later there was some other values about this, like P value and Q value. And then I want to keep them. Filter rows based on ANOVA significant. I want to keep these matching values. And okay. Okay, and it's all. So they already said that we need to do normal z-score before hierarchical clustering. This is again the default. I go to normalization. I didn't change anything. There's nothing needs to be changed for this practice now. And then I do the cluster. And it's okay. Okay. And here, I did the multi-sample test. I have the filter rows. And here, I keep the anomalous significant ones. I apply z-score. I apply normalization z-score because I want to do hierarchical clustering. And then there is this analysis tab. We have clustering. And it's okay. Okay, so after the z-score, I went to the cluster, and after cluster, I could see that there are some graphs, but I need to define the number of cluster. So how I define the cluster, I go to here. It will also tells me, okay, define the row cluster. Okay, let's click. And then here, I go on the arrow. If you just say 5, it needs to be detected here too, otherwise it doesn't recognize. So I suggest always use the arrow. Apply, okay. So what happens that we have actually 6 rows here. Ah, yes, I was not saying it because it was so small. And now here is that we have also nicer heat map that we could see the changes actually. So what are we seeing? We are seeing that this is mitosis, this very phosphoenriched sample, and this was E15, and these are the control group, and we could actually see the differences between these them. And then if you want to know the values, you could go here, and then you will see -3 and 2.5, like which one is upregulated and downregulated. So now I will start after this the more modification-based information. And then this cluster will be also important. So now we prepare our data sets, and we have the clusters, and then we could see the changes on according different groups. And what we will do, we will match this in, no, first I need to export this cluster. So after this, in order to get this cluster information on the second matrix, we have to export them. And then here we will now have some cluster information. Yeah. Clusters. And then I want to merge this information together, so I will have a better view now. And then I will continue with the more modification specific. So I want to copy the cluster information from the last matrix, and my base matrix will be the one before the filtering. I don't want to work on the filtered data set now. I want to merge these two. I take the last matrix, and I take the matrix before I filter to keep the significant hits. And I want to copy the cluster. And then here is important, you need to define unique identifier. You could also have a look on these columns, on this matrix. We have a unique information, unique ID, calls unique identifier. We cannot merge these columns based on proteins because it's redundant information. So now we want to add annotation column, and it was. So we will now add columns. So we will now add some annotation columns. And then we will keep this formation. It's up to you. You could leave as a protein or leading protein. I go for leading protein. And then I want to see the results after adding this annotation. Now I will have some more information as they were mentioning before, some group names and some other names. And then I want to do the tissue exact test. I want to do the based on cluster. So I want to see the enrichment on within the cluster, and I want to see it on the protein level. But I have the information also about phosphor, the site. So we need to do the relative enrichment based on the leading protein that we choose, because we want to count this as a 1. So because this Go terminology is based on protein, not based on the phosphorylation site, we want to do the enrichment, relative enrichment in the end on the protein information that we choose. And then after this step, we go back to the matrix. And then we will start from here to add more modification specific information. And so here on this modification specific information, we already did expand site table, and it said add linear motifs. So here it's also say that these motifs are under conf motif folder. So let's go to our Perseus folder on the conf, and then here this motifs. So if you want to add some specific motifs for your study later, which is not included here, you have to modify this one. So how this motifs file have evolved, it was homegrown, and then we were just occasionally adding throughout the years. And then, so this was the conf motifs information, and this other information is about coming phosphosite plus. So Nonsite, modification count, kinase substrate, and then regulatory sites. They all come from PSP inform, and you need to have this PSP data set. And then these are experimental wise results. Okay, our test analysis is done, and then for this here, we could see like what was this based on this scope term, on this cluster, what was happening. So we could also like our cluster. So you could always go refer your cluster, and then you may be not remembering the names. And then let's say this purple one is 18239, and then this will be something about mitosis. So we could also get this information and then try to mesh this detail based on here. What can we get cluster-based information and go term and category? Okay. Again, I go back to the matrix that I just merged. the information where we have all all this. And then here I will add on the modification. I want to add linear motifs. I leave it as a default sequence window. And on this new, we will have some motifs information here. So it will give us some hint where this, what could happen, this modification, that this motifs with this modification related. So there's a lot of kinase. It's not so surprising. If you have more background about this meaning, what this they stand, you could even dive more information on this. And then from this one, you could again do Fisher exact test. Again on the cluster wise, and I will leave enrichment as none because there could be multiple modification. And then there will be some enriched data set will come, and then we could again check if there's some motifs. Again, I go to the same matrix. So later we could also check side by side what was new column added. So it will be good for you to explore what was going on. So I go to the matrix. I add the non-sites. I choose leading protein. Modification was phosphorylation. It was already selected. The sequence window is default. So let's see what this modified non-site gives to us. So now we have some plus the non-site and this origin. So on the PSP, phosphosite plus, they have different category about this sites previously recognized. It could be CSD, cell signaling technology, or it could be HTP, high throughput, or it could be LTP. So they give us a bit more information. If what you have found is already known there, and on this you could also do the enrichment again. So we add some new columns. Again, I do the enrich, and again cluster and none. So we are almost in the end. So I want to finish this before taking a few more some questions. So we have the kinase substrate relation. It's again coming from PSP. So if you don't see this information on your Perseus, it might be because you don't have the data set. So please check if you have the data set. And you could put this linear motifs, non-site, kinase substrate, all in one matrix. You can, instead of making sub-matrices, you can make one big matrix and work on this. It's also possible. And then on this kinase substrate, if we go, there will be some more information about this phosphosite plus kinase. So, okay, this was been known on this phosphosite plus, and there's a few more information. What about this uniprot ID? So phosphosite plus already give you a hint about the uniprot where you could go, and the number of phosphorylation site has been there. Okay. And again, I went to the same matrix. Okay, and then I want to do regulatory sites. It's again coming from PSP. But please, when you do this PTM, you always, if you are not familiar, go with the mouse and then check what it was written. It might be already some problem you can solve by yourself. Like for this, you don't need PSP dataset. For this, you also don't need, because it's written from conf motifs. But for the others, everything's relying on most of the things, almost 5 things were relying on the PSP, if I didn't count wrong. Okay, so kinase substrate, and then we want to add the leading protein base, proteins within itself. So and in this case, let's see what it adds. So it looks like a lot of sequence. There's a lot of information there. You could see this. Sequence there. We now at regulatory sites, leading protein and sequence window. Matrix is there. So now we are looking for regulatory site information is here. And then this has been known, and this was related to intracellular localization. And then it was related to cell motility. So let's sort. You could always sort the column in Perseus. So it's at the moment it's not so much might be because we still have the earlier PSP information. Cell growth. Okay. So yeah. Regulatory. Okay, so what you can do, you could check this furthermore, this subclasses, and then you could do Fisher-Exact test based on what you were enriching for, and then you will get a bit more information about your PSP. But so let's make one more thing before we finish up. So that was really cool. So we were here. Because I forgot the name about the cluster. So this purple cluster is 1823A. Let's go to the matrix of the after the annotation, and then we cluster. And let's see if we can find some information that's really from kinase related. So now I'm on the Go terms, and then I'm on the matrix 22, and I sort based on the cluster. And then I want to find 18232. Okay. And then this was the category of mitochondria, nucleosome, mitochondria. Looks like a lot of organelle related things were happening on this. And if I go to, let's say, the motif, again, on the cluster wise, I can sort, and I go to the last one. And then, so we could also check on the literature afterwards. Is this motifs, the one that I find, is it related to the maybe mitosis, or it's more than not, it's pure biology you will find. Okay, and then of course you should always save the session. I was doing all without saving. This was good, but you should always save afterwards. And then you could, if you want to export some, you can export the matrix. This is how we will do, and then you will give the file name.